Hi everybody, how are you? In today's lesson, I'm gonna explain the asynchronous programming in the Flutter. So what's the asynchronous programming? If you're coming from another background like Android developer in Java or Kotlin, you almost know about or heard about the threading or multi-threading. So what's the threading? Before you understand the threading, if you want to understand the threading, before that you should understand what's the process. So what's the process? The first thing, what's the process? Any program or any application work in the computer or running on the mobile. I mean just when they start working. This instance of running a program called the process. So the application, your application, Flutter application for example, when running on the mobile, start working in the mobile, create like an instance of this program. This instance, this running instance of program called the process. So now what's the process or what's the program? Program when running, any program, any software when running in the computers or in the mobile application, the program is just like a sequences of instructions, and these instructions need to executed or processed by the processor, and also need a place in the random access memory in the RAM, for example, to store. Needed also the place in the cache memory to store some instruction, right? So the program, you're running a program called the instance of running a program called the process in the machine, in the operating system, called the process. This process or this program, running a program, this instance of running a program, just like a sequences of instructions need to execute it. The first thing your program is run in the computer or in the mobile, just create a default process, one process. After that, the process, create an isolate in the Flutter or thread in the other programming language or anywhere. This is called the thread, but in the Flutter called isolate. So just if you hear isolate, that means it is a thread. So it create a thread in the process, just a single sequence of instructions called isolate or called a thread in the process. So you have a process and the single sequence of code or sequences of instructions called isolate. So inside the isolate, your program will work or your application will work inside this isolate or this thread called main thread or UI thread. In the Flutter called UI thread, or in the mobile application called main thread or UI thread. That means your UI user interface will work in this thread, in this isolate. So now you understand what's the process and what's the isolate or what's the thread. In the Flutter application, you almost just have one thread or one isolate. The application work with one isolate. You need maybe just a very rare you need to create a new isolate or a new threading. But now you can see our program is running in the process, create a default process and create an isolate, work this program. This isolate is working. I say the isolate is just instructions of a sequences of instructions, sequences of tasks that your program should achieve or should implement, right? So the processor, the CPU should execute or implement this task, right? This work very fast, implement or execute your instruction very fast. So this now work with isolate. In isolate you can like this called the thread. This you can add the isolate or thread like this here. And you have a lot of tasks or have task one. For example, you have a lot of methods. You have task one, for example, to click on the button or to print something or to fetch the data from the internet or whatever. Just a task. Also, you have task 2 on the same thread, and just one thread, one isolate. Also, you have task 3, for example, in the isolate. But now, what if the task 2 is take a time or called an time-consuming task? That means this task take a time to implement. I mean, for example, task 1. For example, you want just to make a simple calculation or just a print something. So when you invoke this method or when you just call this method immediately will implement or executing, right? Just to print something. But now the task 2, For example, we want to fetch the data from the internet or to write the data in the database. This take a long time. You can just implement the thread in the one thread. The CPU will implement or execute the first task, the one task, and then the second task. This take a time. So your thread will break, or your thread will interrupt, because this take a time. Your thread is very fast to work, to executing. Your thread is just executing the instruction or the task, implement the task in the very fast way. But task 2 take a long time. So this will break your thread, or will interrupt your thread. So you can see your program is not responding, or your application is suddenly stopped. You have this problem. So if you want to fix this problem, you have two solutions to fix this problem. If you have a long time or a time-consuming task, the first thing, you can create a new isolate or a new thread. Like this, we have create a new thread. This will interrupt or break your application. So you can create a new thread here, or a new isolate in the Flutter, and task 2 work in this isolate. So you don't interrupt your isolate. You don't break your isolate now. You transfer the task to the time-consuming task from the first main thread or UI thread to the another thread. So to just work a background. After this task complete, fetch the data from the internet and work in the another thread or isolate, this task 2. After complete, the result will transfer again or return to the first thread. So you not break your thread, you not interrupt your thread, because the long time operation will work background in the another isolate or in the another thread, and the result, when complete, will just transfer the result to the main thread. It is the first way. But in the Flutter, it is very rare to need using a second isolate or to create a multiple thread or multi-threading. You just work in the one thread or one isolate. So in the one isolate, like this, we have just one isolate here. We have task 1, and the task 2 take a time, not create a new, not transfer to the new isolate. Instead, just using the asynchronous programming. That means waiting for this. I mean the program or the compiler will execute this task 1 and then execute also task 2. But task 2 take a time. Will implement task 2, but waiting for result, and implement task 3. After this complete, task 2 complete, the result task 2 will be here. So it is work in the same thread, in the just single thread, not multi-thread or just one isolate. Just waiting for the result, not interrupt the isolate, because not to stop. The program still working. Begin with that task 1 and then task 2, but without result, and then task 3. After this complete, we'll implement here. You can see the task 2 here. They implement task 1 and then task 3 and then task 2, because this take a long time. This is called asynchronous programming. Now here in the Flutter, work in the one isolate. So it is difficult because the mobile application, there is a multiple task in the mobile application, like a click from the user, for example, click button, there is a timer, there is something in the UI. So here we have one isolate in the Flutter, in the main. This first isolate or the isolate work with the main function, and then you have something called event loop in the just one isolate called event loop. So the event loop, we have a task here, the code 1, code 2, for example, we have a method or tasks. Just implement in the event loop, implement in the one, just in the one thread. External. This internal, there's something in the main function, in the program, functions or task or something like this. But here also external, like a click from the user, the timer, click the keyboard in the mobile and something like this. Just queue it here, dequeue here in the event loop and implement this. Call it event loop. Event loop, just like a loop to implement the task one after the another. And also, as I said, if you have a time-consuming task, one task take a long time, also to work in the same event loop, but waiting for this to complete and then implement without interrupt the loop. Now, for example, you just go to the Dart pad if you want to work with Dart pad, because I just want to using the Dart programming language here. So here I have a main function, I have a task 1 and I have a task 3, for example here. Task 1 just to print something, task 3 also just to print something. It does not take a time, just a task, simple task. So here I want to create another task here. Task 2, I want to make a long consuming or a time consuming task. For example, download something from the internet. Just example here. So I want to add, for example, download function, download file, for example, anything from the internet. This function here, I want to take a time. I want just to print something, but I want to just make it time consuming. So I want to add this function, future, because take time. Here we have duration, have seconds, 6 seconds. And also I have here implement something after 6 seconds. Here I want to implement something or to do something. Here, for example, I want to return. Here I will make it like a result, for example, equal this, and here just return. So this will take a long time, 6 seconds to implement, not like this. Here just a fraction of seconds will implement, and also this just a fraction of seconds will implement. But here take 6 seconds to implement, because just like download something from the internet or do something. Here just example, so I just using the future to just take a time to add the time. So this function here will return string, right? This string, but not just a normal string, because this take a time. So we have an object called future in the Dart. So here the type of this function should be future. Future of what? Future, I want something will return in the future. So here future of string, because after some time the string will return. So to take a time, but this is a string, so a future. Here also the result, a type of it what? Also same thing, future. Here, for example, I want to return number, for example 44. That means it is instead of string, integer, and also here integer. But now I want to string, that means string, but a future, using the future object. That means it is this string will come or will retrieve or will return after some time. So we have this function now. Now I want to implement, to type this function, print something here in the task 2. So here just I want to var, for example, and file or anything equal download file, right? This function here, I just call this function here in the file, and also I want to print this file, print file. That means I should print what? Print the result, because this function return the result, and the result is the file is download now. So here print the file is download now. Should like this, right? Now I want to make it in the, or just invoke it in the, or call the function in the main task 2, like this. Now I have task 1, task 2, task 3, but task 2 here take a long time to implement, because there's a future here. I just 6 seconds here. Now if I run a program, you can see what's happened. See, task 1, task 3, just to return print, because this is immediately implement. But task 2, instance of function or of a future without result. The result is string, but the interpreter or the compiler not waiting for the result, because this take a long time. So just type the first one, print the first one, and the third one. So here, like this example here, implement the task 1, but task 2 take a time. So just implement it, just call this function, but without result, because not waiting for the result. just implement the third one. So here just object without any result. Now if you're using the asynchronous programming, you should do something like this. Go here, because this take a time, just async, that means asynchronous. This function will take a time, and here I should await for this. This take a time, so just waiting for this function. So here now, again run, and you can see the result. Now the 1 and 2 immediately implement, but the 1 and 3, sorry, the 2, now this take a time. After 6 seconds, just the file is downloaded now. This result, because this waiting, the program is still running, but waiting for the result. I mean here, like this here, implement this, and then this just implement but without result. So just waiting for the result, and implement this. After the result come, just print the result here. So you have like this asynchronous programming in the just one thread, in the just one isolate, implement a lot and implement those 3 tasks. The one of those tasks take a time consuming, so waiting for this task to implement and then print the result in this function here. So here waiting for this to come and then just to print the result here. So it is very important to understand that. I hope you understand that. So here also you can see future like this. We have a request, we request for something, we request for the task 2, for example, this, but this take a time. So after some time, I don't know what's the time, maybe it is 3 minutes, maybe 1 second, maybe 2 seconds, 3, 4, 5, I don't know. So after some times, the response will coming. I can see the response. So it is called the future, because this take a time to response. But the future just have one response. In the next lecture, I'm gonna explain the stream. Stream is a different also, but I hope you understand that, and thank you very much.